Hello and welcome to our fifth meeting of CKAD study group. I hope you are well and you will enjoy today's meeting as much as I do, because to be honest, while preparing the presentation, I found a couple of interesting things that were quite new to me and that are quite useful, I can say, in the debugging. Okay, so just before we move on to our main topic, a quick introduction for people who are watching me for the first time. So my name is Łukasz Tomaszkiewicz, but you can call me Luke Tom because it's easier, especially for foreign people to pronounce that. I help developers and DevOps engineers to accelerate their career in the cloud, and I do it in a couple of ways. First, I run two YouTube channels, Luke Tom Cloud, on which you are watching this transmission right now. Please subscribe and give a thumbs up, because it helps me to boost my position in the YouTube algorithm, of course. And the second one is the one in Polish called Kursy Cloud/YouTube, in which there are a couple of videos, actually a couple dozens of videos about AWS I recorded during the last 2 years. I also create online courses. So far I created two of them, Kurs Terraforma as well as Path of AWS Developer. Both of them are in Polish and I really recommend both of them. I also run on-site workshops, so if your company wants to have me on-site to do some kind of training for your employees, then just let me know using the contact email and we can talk about details. And also I work at AWS in Poland as a senior cloud infrastructure architect. I design and deploy infrastructures for AWS customers. Just to quickly summarize, where are we with our agenda? So basically this is a fifth meeting, yeah, that's right. And today we will talk about application observability and maintenance. Next week we will cover application environment configuration and security. I think it will be also a quite nice meeting about that. And then finally with services and networking. And then it's time to pass the exam. So that's how the plan looks like. So today we've got a couple of things related to application observability and maintenance, and the first domain, or maybe first area that I want to cover, is actually around API deprecations. So first let's discuss quickly what are API versions and why are they important. So basically Kubernetes has a life cycle of 3 releases per year, so it's quite often, for example, in comparison to, I don't know, Windows systems, which are deployed every major version every couple of years, and then the minor versions every couple of months, or at the moment once a year, basically. And also Linux distributions also has, I can say, longer period of life cycle. Kubernetes is quite quick, and before there are some new objects in every version of Kubernetes, and some objects are changed, and also some of the objects are deleted. It's important to actually track the changes. How to track the changes? So basically there is something called Depreciation API Migration Guide. This is on the Kubernetes.io website. I will paste that in the YouTube chat at the moment. So here it is. And this is the page that you can see contains all the information related to the things that are changing between the versions. So basically, if you are using any kind of objects here, or you are planning to move to the new cluster, or maybe you're the administrator, if you are not managing your cluster by yourself, is telling you that they will be updating Kubernetes soon. It's good to know what were the changes, and then you probably should to adjust your application accordingly. And what you can find here the description with the grouping of what it's related to. You see what special versions, what special changes were introduced with all of that APIs. And also you can see the API version that is mentioned here. So the most important things that are related to API deprecations are probably the ones with the version over there. I mean, for example, for events, we've got V1 Beta 1 API version, and probably some of the features will be migrated to the V1 soon. It is perfectly possible that there are, multiple similarly looking API groups and API versions for Kubernetes. This is all, related to the lifecycle of Kubernetes. So it's good to know. It's good to track the changes at least, once or twice a year. Just add a reminder in your calendar somewhere similar to just review the changes, so you are not surprised when the changes actually happen. Let's go back to my presentation. And that was the quick introduction to API deprecations. And also most of the sources related to CKAD in the context of API deprecations mention about admission controllers. To be honest, I'm not quite sure it's directly related. API version and admission controllers. However, admission controllers can be used to track those changes. So basically, let's first talk what are the admission controllers. There are two more reasons. I just skipped one slide. But basically, there are new features that Kubernetes introduces. For example, ingress at some time was quite a couple of new features were implemented that changed the behavior of that resource. And also, it's possible that if the syntax changes or specification changes, your application may not deploy correctly. So back to the admission controllers. Why we want to use them? Actually, there are a couple use cases for admission controllers. I will tell you what are admission controllers in a minute, but let's first see what are the use cases and what problems do they solve. So basically, we've got a security. For example, we want to limit repositories on our Kubernetes cluster so they don't get images from the public Docker Hub or other public repositories. Using admission controllers, we can, for example, forbid things like that and only allow our internal company repository to be used as a source of our images. And they can be also used for governance. For example, if we need proper labeling for the pods, then we can enforce on the users that, for example, they should include a cost center label or cost center annotation of the pods or deployments or other things that they are deploying to the cluster. And as I mentioned, we can also annotate things in an automatic way. For example, based on the user that is deploying that, we can mark that as, owner annotation. And finally, we've got a couple use cases related to the configuration management. First of them is adding a limit to our pods and our other services. This is actually quite useful because, people tend to just push the deployments to the Kubernetes without specifying a proper things like CPU limits, like memory limits. And this way, it makes harder for Kubernetes first to schedule that pods and run them in the reliable way, and on the other hand, it also affects the administrators of the clusters because administrators cannot predict what are the expectations for the app and what are the requirements in terms of resources. And this is also a second case. There's also a second case related to the images itself. We can, for example, forbid some kind of images, not only external repositories, but for example, we can prohibit deployments with the latest tag. So we also always need to use some kind of proper version tag, or maybe hashed as a version, or maybe just a branch tag or something that you are using in your deployment strategy. So these are the common use cases for admission controls. Of course, there are many more. Personally, with my experience with admission controllers was related mostly to the things related to security and governance, like I mentioned before, limiting of the images, as well as not using some of the features. For example, we can prohibit using privileged pods and privileged containers within our cluster. So these are the main use cases for admission controller. And now let's take a look at admission flow. So actually what happens if there is an API request, for example, for creation of the deployment or creation of any other resource inside the Kubernetes cluster. So API server actually gets an API request here. And then, it's managed by API handler. And then the first step is to actually perform authentication and authorization. So if you do know the difference between authentication and authorization, authentication is about determining what's your identity, who you are, and authorization is about evaluating the rules. If you are able to or are allowed to access some of the resources that you are trying to access. And then we've got a couple of additional things. First, we've got a first admission controller that actually we can interact with and we can configure by ourselves. So it's called mutating admission. And as you can see, there are arrows here and that contacts with some kind of webhook. What's the idea behind that? Idea behind that is that we can implement some kind of application, deploy it to the cluster or deploy it somewhere else. And then we point Kubernetes that, oh, Kubernetes, you should use that webhook and contact that application because that application wants to mutate some of the resources I'm handling. So basically we are giving a control of the API request and to be more specific to the object that user wants to create or delete or do anything else. And we are giving that control to the external application, and that external application can basically do whatever it wishes with that specific object. So basically, let's imagine that we've got, let's say, cost central mutation admission controller somewhere else implemented, and that mutation controller adds automatic annotation with the cost center based on the user identity. So it's kind of that scenario. So this is the first scenario. And then we've got something called object schema validation. This is, about validating if the object is formatted properly. It validates also if it meets the specification of the specific version of API and the special kind of the object. And then after validation is completed, we've got something that is called validating admission. It looks very, very similar and works very, very similar to webhooks. However, you can see two changes. So basically in mutating admission, webhooks are called in the sequence, and it makes sense because, we want to mutate that object, so we cannot do it in parallel. However, in validation admission, it's much, much simpler because validation admission controller only checks if the object we want to interact with is in proper state. So basically we can implement, for example, a validation admission controller that checks the repository of the container that we want to pull the image from. And by using that admission controller, we are, returning error if this is outside of our company, the URL of the repository, or just accepts the object as it is, by using because the object is using internal repository within the company. So as you can see, this is quite extensible mechanisms. I can say it's not that easy to implement that because not only you need to point to the application, but also take care about all certificates and all TLS authentication for that admission applications that are implementing that webhooks, but it's completely doable. I don't expect on the exam that you will be implementing things like that, like certificates, so we will just cover how it looks like and how you can see what are the admission controllers deployed to the cluster. So on the screen now you can see a sample validating webhook configuration, and this object is actually used to register some kind of service, some kind of application that will be doing a validation of our object. So there are a couple important things here. First is, of course, API version and the kind. By using these two things, you can easily query the existing cluster for existing validation webhook configuration. So it may be, you know, I mean, I can imagine a task on an exam where you are, for example, given a cluster and something is not working. For example, you cannot deploy some kind of pods because validation webhook configuration is invalid, or the application is down and, you know, and the cluster is broken. So I can imagine, for example, a task like find the root cause of that problem, and then you are, you know, listing all the validating webhook configuration objects from the cluster, and then you are checking if the service is connected correctly, and then, for example, removing that object, so, you know, so it no longer blocks the cluster. I think it's perfectly fine task for the exam. So first thing is about kind and API version. The other one is mutating webhook configuration. It's worth, you know, remembering these two names, validating webhook configuration and mutating webhook configuration. And then we've got a webhooks configuration where we actually register the actual app. There are two sections here. The first section is called client config, and here you've got a configuration that points to a specific service deployed within our cluster. So basically, before you deploy that validating webhook configuration, please make sure that that service is working. So I don't know, connect to it with curl or wget or any other tool just to ensure that the service is running properly. As you can see, we've got three parameters here. So we need to point the name of the service, the namespace of the service, and also path. It's perfectly fine to have one service that actually implements many kinds of hooks or many kinds of actions. It's perfectly fine. And then the second section is all about rules. As you can see, we've got an array here, and that dash point here points that this is an array. And you've got a filter, a rule that actually filters all the objects that this validation webhook configuration applies to. So basically what you see on the screen right now is that we are targeting all pods that are submitted to the cluster from API version v1, and regarding operations, we only want to validate an operation of creating a new pod. So for example, if someone wants to delete the pod, it won't be redirected to our applications. Only creation of new pods will be validated against our application configured in the client config section. So as you can see, it's quite nice, quite obvious to use that. The problem starts with certificates. For example, if you use packages from Helm like Cert Manager, for example, Cert Manager implements something called validation service. And this way, Cert Manager provides you the service to validate if your certificate objects are valid, have a proper, syntax and other stuff. What I can say more about that topic? At the moment, Kubernetes custom resource definitions are quite, extensive, and you can describe everything in OpenAPI specification, and you can put a lot of validation related to that objects actually in the CRD itself. However, that was not the case a couple of years ago. Validation webhooks were used to validate the schema of, custom objects that were deployed to the cluster. So keep in mind that there are things like that, and you may encounter it at the exam and have some issue with them and need to fix them. If you have any questions, of course, write them down in the chat, and during the break between the slides I will take a look at it. You need to be aware that there are a couple of admission plugins that are by default deployed in Kubernetes cluster. Of course, it depends on the tool you use, depends on the configuration that the provider provides to you, and not necessarily in all cases you are able to edit that. But in case on-premise clusters or your lab clusters that you are deploying to your computer, you can actually specify which built-in admission controllers you want to run on your cluster. You just need to set that flag in API server configuration file. And as you can see, there are a couple of things. One of the most interesting one is Limit Ranger. This is an admission controller that actually can impose some limits on the resources that pods are using. Then we have something like default storage class that sets the default storage class instead, in case you don't set it by yourself. And there are many more admission controllers here. And this is it related to admission controllers. And let's move on to the next topic. So actually we will dive deep into probes and health checks. If you were following the previous meetings, you probably remember that I also already covered a couple of things related to the probes. We also tested that on the demo last week, where I showed how readiness and liveness probes affect the deployments, affect rolling updates and things like that. And today we will dive deep into that probes and make a quick recap of what they are and how can we configure them. So basically we have three type of probes. First one is liveness probe. So liveness probe tells Kubernetes if the container is alive. For example, it is used to check, if the application is actually running within the container, or for example, if the application is, stuck because it has, infinite loop within the code. So this is kind of liveness. Then we have something that is called a readiness probe, and readiness probe checks if container is ready to serve traffic. And what I mean by that? I mean that some of the application, for example, has a pool of simultaneous requests that they can handle. For example, if you configure an application to handle 10 requests simultaneously due to, for example, resources restriction, then you can tell Kubernetes that you are, at full capacity of handling that stuff, and you cannot take any other stuff, any other API requests. And basically, if you tell that Kubernetes that, sorry Kubernetes, my container is not ready, Kubernetes won't route or won't redirect or push any kind of API request to that pod, to that container instance. So this is especially useful if your application has some limitations or, cannot do more tasks within the container. And then we have a third probe, which is called startup probe. And basically, this is kind of useful start probe, especially in technologies like Java, with Spring Boot or similar things, when it can take even a couple dozens of seconds to run the application, initialize it, and start serving traffic. And in previous, we had to deal with liveness probe and then delaying the initial period. But it was not so good because it led to the situation where we had container restarted multiple times before it was stable, and it was green on the liveness probe, and it was especially true when we had a resource pressure. So for example, if we deployed multiple microservices at once, and the server was busy, so the start of the services were slower, then the liveness probe caused issues. But fortunately, newer version of Kubernetes has a startup probe built in, so you can actually have some kind of endpoint in your application and then set it in the startup probe. And this way Kubernetes probes your application, and until it says I'm ready, it won't send other kind of probes and won't route the traffic to your application. So it is quite useful thing, especially in Java applications. Okay, now let's go to the probing mechanisms. There are a couple of them. First one you can see on the screen is related to executing command within the container. So as you can see, within the container we've got a liveness probe. Of course, it can be anything. It can be here, you know, here in the 15th line, it can be readiness probe or startup probe. Basically, the syntax is the same. And what we have here, we've got exec. Exec section executes some kind of command. As you can see, command is specified as an array. So we've got multiple items, one per line here. Why is that? It's all up to the way that Linux kernel calls applications. So basically, it's you know, safer to specify in that way than the other. You know, with one line with some big string. So this is like that. And then we have a couple of parameters I'm going to describe on one of the next slides. So this is the first way to do a probe. So basically we are executing some command inside that specific container. This is very important that it's executed inside the container. And in here in our application, you can see that what the script does. Actually, it runs some kind of shell script that creates a file here, sleeps for 30 seconds, and then removes that file and then sleeps for 10 minutes. Actually, let's run it and see what happens. Okay, so let's go to here. Let's go to cluster and save that file here. Podliam, and then let's paste it. And now I'm pressing Ctrl D because I'm on Windows. Oh, sorry, I like always forgot to change the window. Yeah, so I actually pasted all the stuff here within my console with the cat command, and now I'm pressing Ctrl D to exit that, to save that. As you can see, it's saved here to the pod. You should learn that trick with, you know, copying from the documentation or copying from any other source, because it may be quite useful during the exam and to actually being able to quickly save files to the console. And now let's run maybe another one console here. Let me quickly run it in background and then move to the screen. Okay, and now we are going to apply that. So cube control, apply, F and pod. So I'm applying that specific pod, and as you can see, container is creating here. And as you can see, we've got one pod that is ready here, and it's currently running. And you will see what will happen next. Within 30 seconds, we should see some kind of behavior related to changing of the liveness condition. As you can see, you can preview the conditions here. So you see that, for example, you can see if this is ready, if this is, you know, initialized, container is ready, and pod is scheduled. This is especially useful if you are scripting something and, for example, want to wait for a specific container. And it's running. Yeah, and as you can see, after 30 seconds after starting, we see that liveness probe failed. So basically, because our script, if you remember, just deletes all the stuff from the container. Here is the line. After 30 seconds, it deletes that file, so the liveness probe of cat, that file, will return error. return error. So you see that liveness probe failed, and after liveness probe will fail for 3 times, and then the container will be restarted. So actually, you know, Kubernetes is able to recover from that kind of errors and restarts the container. So you can be sure that your application is running all time in the container. So this is nice because, you know, this way you don't have to have any kind of intervention from the human, from administrator side or operator side. You just can tell Kubernetes to check that thing, and Kubernetes will take care of that automatically. Yeah, so this is how it works. Let's delete that pod. And let's go back to my presentation. So this is the first thing, and executing the command. There is also another mechanism called HTTP. And basically in that mechanism, we are using HTTP, in that case get command, to actually query our container on the specific port, on the specific path. And in newer version of Kubernetes, we can also specify some kind of HTTP headers, which may be useful, for example, if your application uses some kind of authentication and requires some kind of specific header in order to authenticate the client. As you can see, we can specify that things for our application, and this way Kubernetes will actually query our application, and depending on the result, so if result is, for example, 200, it will be okay. On the other hand, it will, if it's from 400 or 500 family of errors, that will be not okay, of course. What else is important here? Just as a, you know, side comment, that command, that HTTP GET, is executed by the component called kubelet, which is running on each and every node in the cluster. So be prepared in your application to handle stuff like that. If your application is not using HTTP, you can also go with TCP. In that case, you are just specifying a TCP socket that the Kubernetes wants to connect to, and depending of if the connection succeeds to that socket, it's in that case, you know, considered as a success. There is also, as a beta version, support for gRPC protocol, which is mostly popular in languages like Go, but also other. It's getting popular in other languages as well. So this is about TCP, and one good practice. I like to do something like that. I mean, I like to define ports in my application in the style that, for example, we've got one main port that is handling the traffic for my application, like port HTTP here, and then I like to define additional ports for probes. I usually call it diagnostics port, because on that port I usually deploy things, not only things like probes, but also metrics that I want to scrub with Prometheus, and I can also include there some kind of custom endpoints that probably I want to just call to get some additional information about how application is performing. So basically it's good practice, and as you can see, liveness probe can also support the port in the form of the name, so you don't have to care about a specific port number, you can just use the name. Okay, let's go to configuration parameters. I will describe one by one what you can set for each probe. So basically we've got something called initial delay seconds. This is about delaying the first probe. It used to be very useful, especially before we had startup probe. We used initial delay seconds in liveness probe in order, you know, to tell it just wait for that Java Spring Boot application to load, wait a minute or two. But now it's actually more comfortable, more convenient to use the startup probe. It's usually also faster because, for example, in startup probe you can say how often it probes the application to see if it started. In the case of initial delay seconds and liveness probe, we were not able to do that because we had to set it to, for example, 2 minutes, and then Kubernetes at all times waited 2 minutes before starting probing. So if it's possible, you can just skip that initial delay seconds and use the startup probe instead. Of course, you can use, if you only, for example, have one endpoint for liveness in your application, you can use it as well as a startup probe. You don't have to have separate path for each and every probe. Period C seconds, this is an interval at which Kubernetes is probing your application. By default, it's every 10 seconds. Minimal is every 1 second. Then we have a timeout seconds. This is a timeout, so it means how long Kubernetes waits for a reply from your application or for a command to be executed. In case your application takes longer to respond, it makes sense to increase that timeout because, if that time's out, then Kubernetes considers that as a failure. On the other side, you can use that also as a measure of recovering from errors related to degraded performance of the application. So, for example, if your application is getting slower, and then you can use that timeout seconds and to detect situations like that, and then kill and restart that application that is performing poorly. Now we've got two thresholds. First one is a success threshold. It means how many probes needs to success in order to consider that specific container as healthy. And then we've got a failure threshold, which means how many failures we expect before marking the container as failed. So these are the two settings we have here. And then we've got a termination grace period seconds. What is it? Basically, this is something related to how signaling in Linux works. So basically, Kubernetes first sends a seek term to your application. So basically, you can implement your application to intercept that seek term signal, and then you can start shutdown procedure like closing the files, saving to database, or doing anything you wish. And after that termination grace period seconds, if your application doesn't finish, and then Kubernetes sends seek kill, and that means that your application is terminated, immediately. So you've got a chance to handle the graceful shutdown, and this is exactly it. You can specify that in case of that specific probe fails for failure threshold number of times, then you give application that number of seconds to just finish what it's doing. By the way, termination grace period seconds is also useful if your application is using some kind of longer processing. For example, if it takes a longer time to handle each request, or for example calculate something, you can set that termination grace period so that specific request won't be interrupted. So you are giving the application time to finish handling of that thing. Looking ahead a bit, we've got a question. Would Prometheus and Grafana be a good choice for monitoring cluster and node health? Yes, that's correct. I mean, I'm using Prometheus all the time to monitoring my production cluster. And not only clusters, but also other applications as well, and also physical hardware and a couple of other things. However, one thing related to monitoring, I don't use Grafana for monitoring in terms of getting notifications, I use Alert Manager because it's nicely integrated with Prometheus, and I use Grafana, of course, for visualization and creating, dashboard. And also, just a side topic, if you are using Grafana, then there is a project called Loki, and this is also from Grafana, and it can ship all the logs from the cluster to the central location, and this way you can combine that logs in Grafana from Loki and Prometheus, and then you can correlate within the metrics. So for example, you can create, dashboard with some kind of time range, and then if you select the time range, you get all the metrics and logs for the specific thing. I don't have the demo right now. I implemented that for one customer at one project, but it was quite nice, yeah. Okay. However, extending from that, you cannot use that for easily, monitoring in terms of probes. Probes are something that is built in within the Kubernetes. However, if you've got Prometheus, then you can, with Alert Manager, introduce any kind of action, basically not only sending, notifications, but you can also, for example, make other actions like, invoking some kind of automation that restarts app, or rollbacks the app, or continues with blue-green deployment. It's up to you, Okay, and actually that slide concludes things related to probes. Now we've got quite quick topic related to monitoring of Kubernetes application. And I have to say that this is quite quick because we won't get into things like Prometheus. Prometheus is quite nice, but it's a topic for another course or another study group, because it can be quite complicated, especially if you want to do it right. However, we've got something that is deployed in almost any cluster nowadays, and it's called metric server. And what is it? Actually, it's a process within the cluster that collects basic information about resource usage. So different components in the cluster expose some kind of information, and metric server collects all that information and expose them to your applications. You can view that from central place, and as I mentioned, is usually deployed to the cluster itself. Let me quickly switch the monitor again, and this way we can see some of the demo. So basically what you can see right now in K9S, you can see a column called CPU here, as well as memory here, and this information is basically collected from metric server. So for example, if I were to kill that metric server, or disable it completely in the cluster, I will lose all that kind of information. Moreover, in K9S, it's quite useful to see other columns as well. You've got a column called %CPU/R. This is a ratio of percent of CPU used by the application in comparison to the limit to the request value in the resource, and the similar here you've got to the limit value that you specified here. Then you've got the same two columns for memory. So actually, if you allocate some kind of some amount of memory for your pod, then you can see how much memory is used for that specific pod. So this is it. On the exam, you don't have K9S, but you can of course download it if you know how. But you can do something like that: kubectl top pods. And then you need to specify a namespace as well, and kubectl top pods. And then if you specify a capital A, then you can see the same kind of information. It's extracted from the metric server. However, kubectl top doesn't calculate that percentages, so it's kind of sad. There is also a similar thing for node. So you basically can get top node, and as you can see, you've got that percentage, how many CPU is used. and and what is the usage of the memory. And we've got two questions, starting from the second one. What does it mean CPU2? Actually, there is one virtual CPU that is assigned to the Kubernetes is 1000M. So basically, if you want to dedicate the whole CPU to the specific pod or specific container, you just put 1000M. And this way, one VP CPU is allocated to the Kubernetes, to that pod. But as I mentioned before in one of the previous meetings, in case of CPU, it works quite elastic. So basically, if there is no workload or any kind of pressure on the CPU resource, then your application can get all CPUs that are actually allocated to the cluster, so it can use the whole power of the cluster. But if there is a resource pressure and all applications wants to use as many CPUs and as much CPU power as they can, then actually the scheduler here, orchestrated by the Kubernetes parameters, steps in and it allocates that proportionally. So basically, it enforces that proportions between the pods are in place. It's not working the same for the memory. Basically, if you allocate some kind of memory and then your application exceeds that amount of limit memory, the memory is specified in the limit section, and then your application gets something called out of memory kill. And I will cover that a little bit later. And second question is, can you share your ideas what to monitor in production cluster side and application deployment to cluster? So depending if this is on-premise or not, I always monitor not only things like usage and allocation of that resources you see on the screen, but I also like to monitor usage on the node level. So for example, I see if the node is overcommitted and actually is going to have problems with that. So for example, if I allocate more than it's possible and I see that it's constantly using a lot of CPU or memory, then this is a good idea to have some kind of alert for that. There is a possibility to monitor in Prometheus something called number of restarts. So if you have any kind of container that is constantly restarting due to, for example, readiness probe or liveness probe, it's most useful for the liveness probe, and then you can also catch that using the Prometheus rules, and this way you get notified that some kind of application has problems because it restarts over and over again. So this is it. Then when it comes to cluster, you can monitor, of course, the resources for the cluster as the whole cluster. And on the cluster level, I also monitor volumes. If I use some kind of storage and I see that that volume is going to be used at all, then you can get that information. And this is especially important to monitor the storage for the nodes itself, because, for example, if you deploy a lot of versions of application, then Docker images gets cached on the disk, and they can fill the disk up to the whole space that is available. So this is one thing. Of course, Kubernetes manages that things and can remove old images. However, it's not always the case, and I saw the issues with that as well. And Prometheus has one nice feature. By the way, one more thing, on the cloud infrastructure, it's also good to monitor things like, for example, credits for if you are using T family instances, for example, for dev environment in AWS, it's good to monitor credit balance. All the same happens, for example, for boost balance for storage. You can monitor that in case you miss that. And one nice feature about Prometheus is that it can use linear regression for the data points, so you can actually create a predictable alerts. I basically have three levels of alerting. So I've got the critical level. So for example, if it requires immediate intervention to the cluster, then I've got critical errors. And then I have a warning level. That's something that, you know, is going to be a problem if not taken care of, but not immediately. And then I've got also something that I call predictable alerts and predictable level, and that I want to extrapolate the current metrics and see that, for example, my storage is going to be, you know, filled within 2 weeks. So this is also quite nice. And for on-premise things, you can also include things related to the hardware, like temperature of the host, services that are running of the host, and things like that. Kubernetes object state. Yeah, we can monitor state of that things. However, probably it's better to use just admission controllers to not allow the situations where they are broken. Okay, let's move on. Let's go back to the presentation. So that was metric server and two things, top pod and top node. And then we've got also quite quick topic, which is utilizing container logs. It's all about kube control logs. I will show you two things. First thing is related to K9s, because basically this is, you know, for every day, not for the exam, but for every day working with Kubernetes, it's just easier to use. So basically you can point to the pod and then press L. And as you can see, we've got a stream of the logs from that specific container. If there are multiple from that specific pod. If there are multiple containers within one pod, K9s can shows you a prompt, so you can select the specific container that you want to use. The nice thing about that specific tool, I mean K9s, is that if you've got, for example, two replicas of that not metric server, I want to scale traffic. So if you've got, for example, two instances of traffic, then you can press L on the deployment level. And as you can see, it combines a couple of outputs from different pods. So you see two pods and you see them marked with the specific color. And so you can monitor multiple nodes at once. So this is very, very useful. So this is regarding the K9s. And if you want to do it on the exam, then you can use something like that. You need to locate the container you want to monitor. You need a name for it, and then you can klogs, and then you can type kube control logs. By the way, this is a good idea to create a quick alias, so you don't have to. Yeah, I haven't shared the screen, so let me quickly show that again. That's the thing. So basically, we are in K9s again, and then I'm pressing L button, and then I've got. Maybe let me kill that thing, and you know, as traffic is starting. I press L, and this way I get the logs streamed to my console right now. And if I switch to deploy and go to the traffic and, for example, scale that to 3 replicas and then press L, you see that I've got logs from different containers from different pods. Marked with a specific color. So you see this is the pod 1, pod 2, and this is pod 3. So basically you can have all that stuff in one place. By the way, if you need to have some kind of summary of shortcuts, you can press Shift and question mark, and you've got a help with all the shortcuts in the specific context. And as I mentioned before, if you want to do the same thing during the exam, you need to first locate the name of the pod, find the name of the pod and namespace, and then you can just type Maybe let me do it again. Just type name of that pod like that, and then kube control logs name of the pod and then namespace. And as you can see, we've got the logs from that specific pod. If there are multiple containers, you can put a specific container here using a C command. This is useful sometimes. And also there is an F flag, F for follow. Basically, if you run it like that, then you are not only getting the logs that were previously generated by that container, but kube control works in the watch mode, and basically it will stream all the logs from that specific pod to your console as they are flowing. So this is it. Using that syntax is quite, not nice thing. Quite. I mean, you can get quickly tired by using things like that, so I highly recommend installing K9s because it's faster to use. Okay, let's go to the next topic, and this is about debugging in Kubernetes. To be honest, I'm not sure why they call that debugging, because it has it's more related to troubleshooting things, because debugging for me is going strictly to the code of application, and we are not doing so here. But before we dive deep into details, let me quickly summarize what are the most common issues. It's out of my head, but these are the things that you can encounter in your work with Kubernetes. So first thing is pod is not scheduled. This is happening a lot of times. What are the reasons? Reasons are, for example, not enough capacity in the cluster in terms of memory, CPU, disk space, or whatever else. So this is the first thing. Second thing is why the pod is not scheduled. For example, it can have some kind of storage attached, and basically if it has storage like EBS on AWS, it can fail because EBS is zonal resource. So for example, if you create that in the A availability zone and you try to run the container in the B availability zone, it basically cannot mount that volume, and the pod is not scheduled because of that. And it's one of the most common issues when you are using EBS storage, so you should avoid that if possible. Then second issue is pod fails to start. There are a couple of reasons for that behavior. For example, pod can fail to start because you provided a wrong image, or maybe wrong application entry point or command, or you've got some kind of syntax error within the command. But it can be also due to the configuration of the application. For example, you are specifying a database that application cannot connect during start. So basically there are hundreds of reasons why it can fail, and we will take a look at some of the pods later today. And then we've got all the fails at runtime. For example, if the application has some kind of bug, it can just fail, and crash, and the container is stopped. Of course, Kubernetes takes care about that and restarts that container, so you don't have to worry too much about that, but it's good to be able to troubleshoot that as well. Then we've got all the things related to application not working correctly. And what I mean, there's some unexpected behaviors, some stack traces and things like that. And related to that thing, the most useful thing is probably to just collect the logs from the application or increase the level of logging for the application, and this is it. Then we have a whole family of issues, I can say, related to the connectivity issues. There are a couple of reasons for that. For example, application can be misconfigured and listens on the different ports that you've got in your Kubernetes configuration, and there can be a mismatch between the service, the port defined in the service and within your Kubernetes deployment. There can be mismatch between the port defined in the ingress and then within the service, and there can be mismatch between, for example, service that is listening on some kind of host and the load balancer. So there are a plethora of possible cases related to connectivity. We'll take a look at quickly checking the services and endpoints within the Kubernetes cluster. Then we've got out-of-memory kills. So if you are running a production cluster, and because you usually want to have all the resources set for production cluster, so it's more stable from my experience. So you want to limit your application not to exhaust whole memory for the cluster. And you can see that kind of errors when your application is exceeding that assigned limit of memory. So this is it. I mean, for applications, that are developed and deployed in this slow pace, I can see that out-of-memory kills are quite rare. However, I've got a lot of issues with out-of-memory kills when I deployed CI/CD agents to the cluster, because it's hard to predict, for example, how much memory will be used for building application using some kind of, Gradle script or NPM or anything else. Then we've got issues with something unexpected happening in Kubernetes, and this is the time that you dream about having a PhD in Kubernetes, or at least more expertise or experience, because when something unexpected is happening to Kubernetes, it usually means that you need to dive very deep within the Kubernetes. But for the exam, you just need to probably only examine events within the cluster to see what is not running correctly. Then we've got a couple of issues with nodes, starting from exhausted disk space to things related to some kind of applications that are taking memory but were not accounted within the limits of the node. For example, if you are running, node with 16 gigs and then you are running antivirus software, anti-malware, and some kind of other agents that compliance asks you to, but you will not change the kubelet configuration. This way Kubernetes, can clash with that application because Kubernetes thinks it has more memory that is actually available. So these are the sample node issues. Another one can be related, for example, with IP addresses using EKS. If you are deploying applications to EKS, you need to take care about instance size and check if instance size is proper for your use case, because a number of IP addresses that can be associated with the specific EC2 instance depends on the instance type or instance class. So this is also quite common, especially in the microservices environment, that you have too many microservices on one host and some of them are not able to run because of the IPs. Okay, so now how can you actually troubleshoot all these issues using such a simple tool like kubectl? Actually, kubectl is quite powerful in terms of debugging and troubleshooting. I'm not saying it's comfortable to use again. However, you can do a lot. I mean, you can describe things like pods, you can describe things like services and endpoint slices. Let me quickly demo that. Let's go to the cluster itself, and for example, let's describe the above pod. So we've got a command like that, and we can, invoke a description of the pod. And actually, I don't have a so we describe pod, and as you can see, we've got a nicely formatted view. This is basically the same view that you can see within a K9s. So we've got the basic things at the top, and then configuration of the containers, arguments, and other stuff, liveness probes, readiness probes, conditions, volumes, and what may be very, very important for you is to actually check these things, conditions here, and also check events, because events, as you saw before, can tell you a lot about what is happening with the pod, with the container, so within that pod, as well as other stuff. For example, if you've got any issues with scheduling, or maybe with storage, or restarting of the containers, and then here in the events you are able to see what is happening, and usually make some ideas from that. So this is quite powerful thing. Of course, you can also put an output of kube control get pod. If you want to just get a YAML version, you can use kube control get pod, name of the pod, namespace, and then O for output, and then YAML. And as you can see, this is quite the same as we had in our description, but this is fully in YAML. Of course, JSON is also supported, so if you are using it for some kind of integration with other applications, or maybe your scripts, it may be more useful to use a JSON as well. Then we've got the two commands, kube control get service. And that command is especially useful. Let me add capital A so we see all the services in the cluster. This option O-wide tells Kubernetes to include more columns, more data in the output as comparison to the usual get service. You can compare that. As you can see, we've got another thing called selector, and why it's important and why I suggest you using wide version, because it shows the selectors, and selectors are critical for you to have connectivity to your host. So basically, if there is no connectivity between the service and the pod itself, you need to check two things. You need to check port mappings, because ports needs to be aligned. So if you are pointing to the port 80 on your service as a target port, then you have to have that port on your pod defined. So this is one thing. And second thing is, of course, you need to also check the family of the port, like UDP or TCP. But it's just a side note. And the second thing that can cause trouble and connectivity issues between the service and pod is the selector. So for example, if selector is not properly configured here, or maybe your pod is missing some labels, and then it may happen that traffic is not flowing to that specific pod. So by using this one simple command, you are able to basically check the services. And we've got one more command that can be quite useful for troubleshooting. It's called kube control get endpoint slices. And endpoint slices, what it tells us? It tells us about the specific endpoints we've got here. Just to show you that in the better way, let's deploy 3 replicas of traffic and see what we have here. Yeah, so as you can see, if you are deploying any kind of pods here, and there is a proper mapping between your labels in the selector of the service and then labels on the pods, then the IP of that pod should be, show up here. So as you can see, I've got 3 IP addresses here, so that means that actually my service discovers 3 pods from with that specific selector set of labels. And that means that labels are okay, and probably I should move to the checking of the port of the service. So this is like that. So it's quite quick, to diagnose issues with services and pods using that 2 commands, and also, by checking the labels here in my pod using kube control describe. You can see labels over there. Yeah, so this is it. This is about describing objects. Then we've got something that is called exec into container. So basically, let's see what I can do with my traffic. I can, for example, let me move up quickly. Let's see if the pod is still running. It is. So now I can execute some kind of command. So for example, let's call exec, I don't know, ps. And that specific command will be executed within the container itself. So as you see, I'm telling Kubernetes to execute a ps command. These two things, two dashes, are critical because they say Kubernetes that the rest of the line is something that should be actually executed within the container. Before that, two dashes, it's all the parameters of the Kubernetes. And as you can see, that thing was executed within the container itself. So I can do things like ls or other stuff. And this way I can, do anything I want within the container. Like describing the files and checking that. There's also one more use case that can be quite useful. I've got that probably on my next slide. We can actually get a shell in the container. So basically by executing exec and adding IT here, I is from interactive, that we want to have interactive session with that pod, and T is for TTY, and this is a pseudo terminal that is allocated for that specific thing. And by specifying a shell here, we can get a shell within the container. So I need to add IT here, and then I should get a shell within the container within a second. So as you can see, I'm inside the container right now, and I can, for example, check, what's happening within the container, if the application is running. I can check the configuration files, what application sees, and do all other stuff. So this is quite nice feature. So this is all about shelling into the container. Then we've got something that is called shell into cluster. So in previous example, I wanted to go into specific container to examine application or configuration for that application. But sometimes you just want to check something from the cluster level. For example, if cluster has connectivity with outside world, or you may want to check things like if the service is reachable from other microservices. So you can execute things like that. Let's copy that and see what is happening here. We are running kube control run. Oh, and it's not working. Probably something changed because I just updated kube control before today's meeting, but we can skip that, I think. Yeah, and what happened here? As you can see, we've got, of course, I and T. We've got a name of our pod that we want to deploy. We've got the image we want to run. We are telling Kubernetes to never restart that container, and then we want to get shell. And if we go to the cluster, let me quickly clean up things here. Pods. You see that we've got a new container over there called BusyBox that was run in the default namespace. So basically, I'm able to see the things in the cluster right now. So, I can, ping Lookdown Cloud and see if I have connectivity with that website, or I don't know, do a cool kind of stuff like, by the way, the thing I'm showing you will be on one of the future videos I'm going to publish on Lookdown Cloud. Oh, we don't have curl, so we can do a wget. And as you can see, it's not working with the certificates because we miss certificates within that specific container. So it's kind of thing. By the way, I'm soon going to publish things related to building a home lab series. So I highly encourage you to subscribe the channel if you haven't already, because it will be quite interesting. And now let's quit that specific container. As you can see, the pod terminated. it's no longer here. I mean, it errored on the cluster, right? To be honest, we can kill it and it's out of our cluster. So this is a scenario when we want to shell into the cluster. Oh, and I've got presentation that is broken. By the way, I'm creating that presentation in Markdown, and this is quite nice feature that you can use. And there is a library called reveal.js, and you can use that for quickly generating the presentation. So this is quite nice thing. Then we can shell into the node. So for example, if you've got any kind of issues, of course, you've got the possibility, to connect using SSH, or in case of AWS, you can use Systems Manager, Session Manager to get into the cluster in the secure way. Look on the Kursy Cloud YouTube channel, there is a dedicated video about that in Polish. But in case of Kubernetes, you can use a special command called kubectl debug. And then you can run a specific, you can run a container on the specific node. So basically I need to go here. I need to list all my nodes. And then I need to execute things like that, but I need to copy in the name of the node. And this way I should get into that specific node, and here it is. I've got a Ubuntu container running inside the context of my node. Of course, there's one thing. This container is not privileged by default, so you cannot do all the things related to the node. But as you can see, it's running without the isolation of IPC or namespace on the kernel, C group on the kernel. So you can see the preview of all things that are running on my server. If I want to access the file system, I can go to host. And here is the file system of my node that is running the container right now. So it's kind of cool because, I don't have to care about SSH. I can even close SSH port, so it will be more secure for my node to be exposed anywhere, won't be exposed anywhere. And I can just use that trick with kubectl and debug to do things like that. So it's kind of cool, I can say. Yeah, and as you can see, at the moment that specific pod has completed, so I can delete that from the cluster. So that's kind of nice thing. By the way, you can do most of these things from the K9S. For example, I can go to traffic and press S, and then K9S opens a shell within the container, so it's quite nice. The same things happens with Node. However, for Node, you need to set something in the configuration of K9S, because by default, it doesn't allow you to do so. But there is a possibility like that. You just need to find it. Where is it? Where is the shell? I don't see it because probably it's disabled. However, from K9S level, you cannot run a new container with cluster level shell, so it's different story. Then we've got something called ephemeral containers, and this is also quite kind of cool feature in newer version of Kubernetes. For example, I write in the couple of languages. I write applications in the couple of languages like .NET, like Go, like TypeScript and other stuff. And this is especially true and useful for Go applications, because in Go applications there is a possibility to compile your whole application to one binary file. So you don't have to have the whole big base image with, I don't know, Ubuntu or Alpine or anything else. You can just create a single binary container, and this is quite nice feature in terms of security as well as the speed of the deployment. But there is one thing: you cannot shell into that container. Why? Because there is no shell over there, because you've got just one binary with your application. And it used to be a problem. Some applications deployed multiple versions of the same container, for example, one with single binary and then second one called debug version with additional shell included. However, in recent versions of Kubernetes, you can use something that is called ephemeral containers. And what is it? Basically, let's start a container that runs some kind of task. As you can see, we are running a special container called pause. Pause container does nothing, it only waits. Pause containers is quite often, you can meet it quite often in Kubernetes because it's used as kind of zombie reaper thing. I'm not going to explain what are the zombies in Kubernetes, but this is quite important thing if you think about running Kubernetes in production. Just read about zombie PIDs and zombie processes in Kubernetes. And pause containers is usually used just to reap that things and deal with zombie problem. In our case, it's just running, a single binary, and as you can see, we cannot go with shell to that container because there is no shell. As you can see, it fails. If I were to get pods over there and try to exec into that, so if I try to exec it demo and then I want to run shell, you see that there is no such binary, not found in path. And to be honest, in previous versions of container, I at that moment ran out of options, but in the newer version, we can do something like that. So we can basically deploy using a command called kubectl debug, we can deploy additional container to the existing pod. If you remember what I said a couple of meetings before, I said that things like pod are immutable. So actually that was not entirely true. If you are using low-level APIs, using something called raw API, you can actually replace some of the parts of the container. And this is actually what kubectl debug command does here. So basically it adds additional container here to my pod. As you can see, we've got a new section called ephemeral containers, and as you can see, BusyBox is currently running within that pod. So now, as you can see, I'm actually in the shell within that pod, ephemeral demo, and I can, do things like examine all the processes that are running here. I don't have access to the file system of different container. However, I can do it with, volume sharing or things like that, of course. So as you can see, it's quite useful. Even for the distro-less binaries or single binary containers, you can do so. More of it is within here. It's quite useful. You can see a couple of scenarios. It's good to get familiar with possibilities of that single tool. However, you don't have to memorize all of that stuff because Kubernetes IO documentation is available on the exam. So you don't have to memorize it. And then finally, we've got one of the last things, but not last. We can get, I'm not sure if we are going to get anything because, sorry, I copied something else. Let's copy that specific line. There are a couple of things. Using kubectl get events, we can get a preview of what is happening within our cluster. So as you can see, there is a lot of happening due to the things I did with my traffic container. I scaled it up, down, and did other stuff. And as you can see here, we've got a summary of all the things related to that specific namespace. Of course, you can see for the specific container using kubectl describe, as I showed before, but this is useful in case you want to troubleshoot the whole cluster or maybe see what is happening with multiple microservices. If something is not stable, then probably you can get a view here by examining what is happening. So this is it. And final thing for today is a quick command. This is actually not related at all to debugging, but can be a nice trick in order to get your pod out of deployment and out of service. So basically by using kubectl label pod, name of the pod, and then name of the label and dash at the end, you can remove that specific label from your pod. And the question is why you want to do it. Yeah, why would you do it? So there is some reason. I've got, for example, application that fails somehow, has some kind of logs within that pod. I don't want to kill it. I don't want it to have you know, all things related to that application managed by Kubernetes anymore. So I can remove that specific label, and this way that pod gets out of service, for example, or gets out of deployment. And this way I can, you know, leave it in the cluster, so Kubernetes won't delete it for me. So it's quite useful trick. If you don't have time, for example, for troubleshooting right now, you can get that pod out of these things. Okay, and we've got two more questions. Actually, they are sorted by date. As you can see, this is the oldest one, and this is the newest one. So they are sorted, but in the different order. How to sort them? To be honest, I don't know. There should be something here in the details. To be honest, I don't use kubectl a lot. I usually use it, especially in the scripts. I use K9s. Good questions. I don't know. And the second question is it possible to expose API object options over HTTP? What do you mean by options? Because, you know, basically API server is doing exactly that. It exposes API objects over HTTP. I mean, kubectl is just, you know, a kind of tool that wraps API of Kubernetes, HTTP API of Kubernetes, and doing some of the magic stuff like, I don't know, watching for resources. But Kubernetes is actually exposing that using API servers. Yes, you can do so. You can go here, and of course you can, this way you can sort them as well. I can say here we've got but first scene and last scene. So here with Shift and L, I can sort by last scene. So that may answer your question. So this is the thing. So you've got all the things related to the events. Here in that case, it's in all namespaces. kubectl explain. Let me show you quickly. Let's get some kind of pod, for example. Type of resource, for example, explain pod. And what is it? It is, you know, a context help. This is just, you know, if you want to have something like that, you can use it, especially during the exam. For example, if you are not sure about the specification of the pod, then you can just go here using that link, and it will, you know, move you to GitHub. Unfortunately, I'm not sure if you can go to the GitLab during the exam. You can go to the Kubernetes you can. You are allowed to see the whole documentation and whole source code of the Kubernetes. So actually, as this is the same repository, you are able to do so. So you just click here, and then you can see all the documentation, all the spec. If you know Go, then it may be also useful, you know, to get familiar with that. To be honest, Kubernetes is written in a very, very nice way. It's both to the efforts of contributors as well as the Go language. It's quite quick. You can locate the code that does a specific thing. And to be honest, I use it a lot. I mean, I've got some issue with network load balancer in AWS, and then I got to the implementation of load balancers in Kube Controller Manager, and I was quickly able to find out the things out. Sure. Yeah, we will do a quick Q&A probably next week. I plan to do so on Tuesday, but unfortunately I've got a couple of things that prevented me doing so, but probably next week I will send a mailing about that. And basically that was quite interesting meeting from my perspective, because I also learned a lot, especially related to kube control debug. It's quite useful. So next week we will meet and discuss application environment configuration and security, so also kind of nice stuff, and then services and networking. If you have any questions, you can send them always to me or just write in the chat. We've got a couple of minutes. I can speak, I still can speak, so I can answer one or two more questions. I will wait a minute, because there's some kind of lag in YouTube. Okay, so if you don't have any questions, then have a nice evening, and see you next week on our regular meeting, or maybe on Q&A meeting. See you soon. Bye.